Okay, so for the cutter holder, I have just really one requirement, in that obviously you have to make it dimensionally correct. But I wanted to kind of give you one hint on the sketch part. When you look at the drawing, whatever the orientation of the drawing is, you would do well, and it's going to serve you well if you use um, the default views. So I think the front view maybe has this pattern. I missed this here. Let's see. Select that, delete, and come on. So it has this pattern, and I'm just going to extrude this out, and I'll do, let's say, a mid-plane. It'd be 30, something like, let's do 40, something like this. So it's going to be very helpful for you if you actually use the default plane. So when I have a front view, this is the view I see. It's not required, but I think that's pretty helpful. Another thing I'll do is I'll just do another sketch. I'll kind of go, let's do a corner rectangle to here, and then maybe another corner rectangle here, and then I'm going to go features, cut, and let's just go through all. So this can be obviously dimensioned. So, and then I can do the slot on this face. But there's another issue here on this, and that is if I go to the right view, I go to the right side view, there are rectangles here, and there's slots here, and I'm going to put one here like this. I'm going to put another one here. The center is equal. The depth of these is, well, I can't dimension accurately because I'm in metric, but the depth from this edge here to the bottom of the slot is 19 thousandths. And the way it's dimensioned, there's a dimension here. There's a dimension actually here from this edge to this edge. And I'm going to make this and this line equal in size. And I'll actually even dimension this, whatever this size is. And I'll make this line and this line equal in size also. So this is pretty much fully defined, except for you can see these lines are blue here. So there is a dimension of the length of the slot, the depth of the slot, and the distance between the slots. However, there is no, in this case it would be a vertical dimension from this edge or from this edge. There's no vertical dimension of what that dimension is. So you could actually technically put these slots anywhere along this vertical edge. They're missing a dimension there. So another option is to go over maybe on this side, get to this midpoint, do a horizontal construction line and select these two inside lines and this construction line. So I've got this line selected, this line selected, this line, and you could put the construction line on this side, doesn't matter. And I'm going to say symmetric. And now you can see that it is fully defined based on it's locked into the center point of this edge or this edge. But this dimension is not shown on the drawing, so I can't hold you to that. I can hold you to the depth of the slot, the width of the slot, and the distance between the slots. And then, so from here, I'll just do another cut. And let's go through all. And done. And that's what it kind of looks like. The slots. Okay. There's actually another slot down here. This bottom portion, I did this a little bit incorrect. This is not exactly like the drawing. But I believe if you look at the drawing closely, this bottom part actually has another 19 thousandths edge shoulder on this side. But that's one that's really hard to see. The drawing's not very good, so I'm not going to hold you to that. But I'm going to hold you to the using the hole wizard. So I'm going to go through that again right now real quick. So I'm going to, let's see, the hole wizard just shows the thread part. I noticed the cosmetic thread is kind of a default now on the hole wizard. This thread part, it's okay, but this is really good for when you have like a larger thread or you have a boss sticking up that you want threaded. For the design aspect, I think this is a little too involved. You don't necessarily need this, and you certainly don't need it for to communicate the feature. I think it's more of an aesthetic thing for, in designing. So I'm not going to use the thread part. I'm going to use just the hole wizard part. And I think I went over this before, but again, there's two tabs here. There's a position tab, and the hole wizard property manager starts with the first tab, which is the type. And there's 9 options here. There's counterbore, countersink, hole, straight tap. This is a bad name. This should just be called threaded hole, because you can make a threaded hole without a tap. So I don't like that term. Tapered tap, what's called a legacy hole, and this is they have, I forgot what they're called, porting tools, and you can kind of design your own custom porting tool and have that within your selection as a legacy hole. And then these are counterbore slots, countersunk slots, and then just a regular slot. So this is done as a feature, whereas we usually do slots like as, we do slots as sketch entities and then extrude them. I think this might be easier if you have like multiple slots and stuff. This might be easier to use it instead of just going in and sketching, because all you need for these is you need just the hole locations on the positions, and then as far as the counterbore and the countersink slot. The regular slot, I don't know, I would just as soon do that as a sketch, but maybe if you're doing multiples of them, it might be easier to use it in Hole Wizard. So for us, I'm going to want you actually to use both on this assignment. We're going to use the straight tap as well as the counterbore. So I'm going to first use the straight tap. It's usually the default setting. You can see it's a little bit gray. If I select another box, it kind of grays it just slightly. So I'm going to select the straight tap. And then you don't have to change the inch. This is different different nomenclatures and different standards that they use, but the ANSI inch is usually pretty typical for the United States. Sometimes in Europe they use ISO, and there's some other I think some of these other standards are for just for the thread. And then for the type, there is I'm not real sure honestly what the difference between the bottoming tap tool. It does default to a bottoming tap where the lead of the tap is only 3 threads. A normal straight, well, a normal tap tool would have a lead thread of 5 full threads. So it would actually, within the profile of the threaded hole, you would have the tap drill, or the minor diameter drill size would be drilled a little bit deeper as opposed to a bottoming tap hole. Sometimes you don't necessarily need to specify that in the design, because the builder should know that what the lead of the tap is, and there's formulas machinists use to quickly figure that out, so that the tap drill or the minor diameter does not break through the bottom of the hole. So a bottoming tap hole is one that is not a through hole. A tap tool would be considered a through hole, which would you would almost always put this as a thread completely through the hole from the face of the top of the part all the way through to the bottom, so that the screw can actually physically go through the entire part. And then the straight, it says a straight pipe tap tool, but I'm not sure what this is. I think this might be a specific thread call out that's a little bit different, but I'm not sure on this, because most pipe thread is tapered, and it actually is the same 60-degree angle of the thread of both of these, so I'm not sure exactly what this is. Let's go to the hole specification. This is on the call out, and it shows here as ANSI inch, so these threads are going to be inch threads, and it starts with a 0 to 80. These are specific thread call outs, and it from 0 is a very, very small thread all the way to just before the 1/4 inch thread. It's a number thread that is very specific. It has obviously the threads per inch is the second number. So if you measure the full rotation of a thread, let's say on a 640, there would be 40 threads per inch on this particular. This is a very fine thread. And then the number here designates the major diameter, not the minor diameter. The minor diameter is actually drilled. When you manufacture this, you would drill with what's called a tap drill, which establishes the minor diameter. It leaves enough material for the tap to go in and cut the thread. So this is, again, the major diameter and the threads per inch, and we're going to select on this one, let's select 1228. And because I'm in the custom, I'm in the metric option, it shows this actually as metric. And I think on yours, yours is through. So I'm not going to select the bottom. I'm going to select the tap tool, and you can see it shows bottoming tapped. So this is what we call a blind hole. Let's do the tap tool. And the end condition, see, it doesn't change the end condition here, which is a little weird. I'm just going to go through all. And then the depth of the thread doesn't matter, because it's going to go through whatever location I have. Now on the options, this is more of a display. They should really probably say on here display options instead of just options. And this shows with the thread removed. Sometimes you might want to do this in design just so you can see where the thread will actually cut if it's close to another feature that the threads might weaken another area of the part. And then this one is just the tap drill diameter, and this is kind of an old standard, because if you put the minor diameter of the thread or the tap drill size in your design, and all you had to do was specify that diameter of that tap drill size, which is also the minor diameter size, or falls within the tolerance of the minor diameter of the threaded hole, then the machinist can just look at that tap drill and look up on the chart, and based on that diameter he would know what thread you're talking about. So on the design part, on the CAD part, you really didn't need to even have a drawing. You just specify the minor diameter and you're done. So but the other option is this, and shows cosmetic threads. So this is kind of the newer version. This is the version I like. I would say definitely use this. I'm not going to mark you down if you don't, but you can play around with this when you do this and change this. The rest of these features here, it does show a near side countersink, and I think the defaults on these are kind of big, honestly. But they are based on the machinist handbook. On this one, I like to go, it's a 1228, which I think is I think it's like 212 or something. It might be 236. So this countersink size, this is the diameter. I probably wouldn't have this larger than 240 or something. Even on a near side countersink, even on a 1/4 inch, I would have this at 260 thousandths countersink diameter. And then it's funny, the default here is 100 degrees, and I don't think this is correct, because the default spot drill is actually 120. And I'm pretty sure that's the call out for within the machinist handbook. So I'm not sure that's correct on the angle of the countersink. And this angle, actually, when you're manufacturing, this angle really applies to the type of drill you're using, because there's different drill tips. The standard drill tip is 118 degrees, and if you use a 120 degree spot drill, it's perfect and allows for the tip of the drill to start cutting within the drill with 1 degree clearance on both sides. So it engages the cutting lips of the drill tip, or the drill, quickly and evenly. And if you use a 120 degree spot drill, you're going to get a much more accurate location. Now on softer materials like aluminum, a lot of machinists will use just a 90 degree spot drill, and they can actually even establish the countersink, which is larger than the thread, the major diameter of the threads. The problem with a smaller spot drill, a smaller angled spot drill like a 90, is that it doesn't engage the drill at the tip of the drill. It engages the drill in the middle of the cutting lips, and you have to actually get down, not that deep, but you're going to be doing some cutting with the drill on specific locations on the cutting lips, instead of over the entire face of the cutting lip. Okay? And if you haven't taken a machining course, you probably should. We'll have 158 offered in the fall. And I go through that extensively, and you actually do a couple different versions of that. The other aspect about the countersink part is, You have a 120. You have also a 90. The one reason why the 90-degree countersinks are used is because you can very quickly calculate the countersink diameter, because it's a 90 degrees split in half is 45 degrees, which gives you a I don't want to say isosceles. I don't think that's isosceles, but it's a symmetrical triangle, and you can if you double the depth, whatever the diameter you want to get. Let's say you want a 100-degree diameter countersink. From the tip of that 90-degree spot drill, you would go down 50 thousandths, and that would give you a 100 thousandths diameter countersink. Okay, so it's a little bit easier to calculate. You don't have to worry about that too much, because on this one it actually calculates it shows you the diameter here already. So they actually do both. The far side countersink, this applies only for a through hole. So a lot of times, I say a lot of times, but I've seen drawings where the drawing will only have this view, or let's say this view. Okay, so you might have holes along this face or something, and then there's through holes, and they have countersinks on the other side. And actually, I'll show you what that looks like on this, because I'm gonna it will make this countersink. Actually, if you turn it on, you have the exact same option, and you can see it's from the back side. It's underneath, and the underneath angle, in that case, it shows 90 degree. I don't know why they defaulted to 90 on that. And then actually the default also was not 266, not based on the major diameter, it's based on the minor diameter, which I kind of find that a little funny as well. But I'm pretty sure if I turn this off, and let's see, if I go to blind hole, I think this will go away, I would think. Yeah, so you don't have an option for a far side countersink, because the thread is going to start on this face, but it's not going to break through this face. So hopefully that clears up any question you have on the options. When you get in here, though, play around with this a little bit. You know, select this, and if I remember, I'll go back and we'll look at this. So I actually have this selected for blind. This is the blind condition. This is the blind hole depth, and this is for the blind hole. This is for the tap thread depth. And I think on the drawing, or some of the other drawings that I had done, maybe on the midterm even, I had said, I had given a depth, like a 375 depth symbol, which is like it's like, does it show it here? It kind of looks like this. It shows a line with an arrow pointing down. That's the depth, and the drawings often say full thread, and that means that your fastener has to rotate to a complete depth of 375 or whatever this value is here. In this case, it's 10.97. Now, if you notice on the end condition, this is a blind hole. So what do they call this here? The blind hole depth has to be deeper than the tap thread depth. Otherwise, if I go in with the tap, I'm going to bottom out my tap and I'm going to break it. So let's see, if I change this, to 10 millimeter, this doesn't change. I'm not sure why it doesn't change, but let's try it actually the other way. Let's go to, let's Let's go and make this one 8. Yeah, in this case it doesn't change, so that's a little odd. You got to be really careful. I think if I did it this way, this is my tap thread depth. I'll go back to 15 and we'll see what this looks like when I put this in there. So now, and I'll go back and I'll change this and we'll take a look. Now I'm going to select the tab positions, and it asks me select the face, the hole, or the slot. So I'm going to select this face, and right when I do that, it shows the preview. And it might be a video issue for me, but it doesn't show the center mark, the blue point. So let me see if I can go view, hide, show points. See, that one doesn't show it either. View, hide, show, axes, sketch planes, dun, dun, dun. I'll try origins too. Let's see. Well, it showed it. Yeah, it shows it now, but I had already put those in position. So I'm going to drag this one down here. And I have these two. Now, it shows a pretty good preview. This is a really good preview. It shows the countersink, so I'm going to actually say yes. And you can kind of see this line right here is the major diameter. This line, or this diameter, is the countersink diameter. And you can kind of see in the bottom, see how the threads go all the way to the bottom of the hole? That's not going to work because my tap would break. So I'm going to actually change this a little. Let's go back to our features here. And I'm not going to change the end condition, but I'll change the depth. So the depth will be 5 millimeter. I'm going to say yes. And now you can see this is the minor diameter is drilled deeper than the threads. The minor diameter or the tap drill is drilled 10 millimeters deep. The thread or the tap is 5 millimeters deep of full thread. So if I had my 1228 bolt, I can screw this in exactly. It would screw into an exact depth of 5 millimeters. And now you can see again, I think this countersink's too big, so I'm going to go back in, edit this, and I think it's even like 2. It might be 196. So if I go like, yeah, because I think it's 196. So if I go to let's go 205 and done. Greater than 216. Okay, so that's what they're saying. I don't think it's that big. So I'm going to go to 218. I'm going to say yes. The countersink doesn't really matter to me. And you can even not have it in there. It's fine. But for the design purposes, you almost always want to have it in there. And the machinist is going to make a countersink on any threaded hole. They're going to have this with a countersink for sure. So now if I go back through and edit this as well, dun, 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 let's go to through all, and there's no depth of the thread. It got rid of all that end condition for the depth of the thread because this thread, it goes all the way through the part. So this is not a blind threaded hole anymore. This is a through hole. And for the most part, when you see on a drawing where it says it gives a call out for a thread and there's no depth of the thread, well, that's a through hole. Most of the time, I think they should always see where it says 1228 through or something. So it would look like this. And I think on your project it is through. So hopefully that helps. Let's change it one more time. I'm going to go in and change this to, dun, 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 let's turn on the far side countersink, and I'm just going to go with the defaults. And this is what the far side countersink looks like on the back side. We have tapped from this side with the countersinks a little smaller on this side. So it's a little bit of an edge break. I don't know. It would probably be deburred by a machinist. The far side countersinks is usually a specific call out, not just to deburr it, but maybe it might be threaded from both sides. I know a lot of punch dies are that way. But on this, you notice within our property manager for the threaded hole, it shows, it has this sketch 5 here at the bottom. This is the thread profile. Okay, so this is based on the information within our feature. And then it has sketch 4. This has a minus sign. This sketch 4, you have to go in, and this relates to the location of the center of the hole. So you've got to go in and dimension this from here. You're going to have to do from both edges here. So it's defined, and you'll see if you zoom in, maybe not. This is black. This is fully defined. But this hole position is not. So I'm going to go in and also add this hole position. Yes. And then I'm going to make this. Dun, dun, dun. Let's make these two hole positions. Both point. Let's make them, is it vertical or horizontal? It is vertical. Done. So now it shows both points as black. It shows the minus sign still here, but once I exit this sketch, the minus sign will go away. These two hole locations are fully defined. So I'm looking for that as well. And then on the counter bore, I'll do a real quick counter bore on this face. Again, Hole Wizard, counter bore, not taper tap. This one counter bore, and I think it's custom sizing on this. So I'm going to go to custom sizing, 1228. I'm going to actually just use all of this. Maybe change this depth to, let's say, 60 thousandths. And then the end condition, so the hole, the counter bore has a depth, but the small hole, which is 228 diameter, or they call this the tap drill diameter. This isn't a threaded hole, but they still use that terminology, tap drill diameter, right? Because this is a counter bore. I'm not going to do a far side countersink. And I don't even like doing, on the counter bores, generally you're not going to put any countersink, even on the near side. I'm going to go to positions to this face, and this is what it looks like. And you can see this actually does have the near side countersink, so I thought that was turned off. Let me make sure that is turned off. No countersink, done. And then that goes through. And then again, on yours, you're going to have to go in and dimension this from edge to edge in both directions, and then maybe make these vertical or horizontal to each other. It might be hard to tell on the drawing, but on that particular drawing, on the counterbore holes, the counterbore actually violates the radius of the edge. It's kind of got a large radius there. So, but that is correct. And if you look real close on the drawing, I think you'll see that. So don't be surprised if part of your counterbore feature is cut away based on the radius edge of the part. So I think that's it for now. This project was just use your skills. This is you. There's no book anymore. This is the practice of you getting out there and using SolidWorks professionally. Very similar to obviously the test. Maybe the part's a little bit harder, but starting next week, and I'll probably put it up shortly. I'll do the assembly, and the extra credit drawing will be coming soon. Certainly at least by Monday. Okay, thank you.